Hey Darryl, I've got a customer that wants to bond a strain gauge to carbon fiber. What kind of things does he need to watch out for as opposed to like bonding to an aluminum beam?
Mark, that's a great question. And we've actually put together a couple of things to help customers that are interested or involved in composites testing. And one of those things is this PowerPoint presentation that I'd like to take you through that helps to illustrate some of the things you need to be thinking about and some of the tests that are typically used when you're testing composites as opposed to maybe aluminum or steel structures. So this PowerPoint presentation, we'll get started here. And here on the first page, we just show you some examples of some different types of strain gauges that we found that have been quite popular for composites testing. And we've been developing some new patterns too over the last few years to try to meet the needs of these customers, because there are some unique conditions where maybe the geometry of the strain gauge has to be modified some to fit a certain test fixture. And so over the course of the next few slides of this PowerPoint, we'll take a closer look at that. So first off, really, when you're talking about composites testing, typically you can lump it into two categories. It's either structural testing, a full-scale test article like the Boeing 787, or you're doing coupon testing. And oftentimes you start with coupon testing and work your way up to testing the actual structural article. And as far as the strain gauges, we have traditional types of strain gauges that can be used for composites testing, as well as our advanced sensors group is also developing some new gauges that can be used in these types of applications. So here you see a slide showing some different coupons. The first one there is got a traditional strain gauge on it. That's one of our CEA series 187 UV strain gauges. That's a dual shear gauge, and it's used in a shear application to test this composite fiber reinforced panel. These CEA series gauges are widely used for general purpose testing, including composites. In addition to that, they're capable of strain levels up to about 5% strain. And most of the time in composites testing, these CEA gauges, they're capable of a high enough strain that you're not going past that with the behavior of the composite. Some special considerations that we're going to look at over the course of the next few slides is we'll talk a little bit about the gauge selection, a little bit about adhesive selection, a little bit about what you do to get the surface ready, because it's a little bit different than what you might normally do with a metal. And then as we near the end of this, we'll take a look at some instrumentation and maybe some special applications as well. So this next slide shows two different strain gauges for two different purposes. The first one is one of our newest CEA series gauges, and if you look at it closely, what you'll see is that the tabs are off to the right side. We do this because this gauge is really intended to be used on a compression test of composite materials, and there's a very small half-inch long window to get the strain gauge installed and to get the wires out. So what we found is that it's a lot more convenient to put the tabs on the side as opposed to in line with the gauge, and that allows our customers to take the wires out the side as opposed to being in line with the coupon that sometimes can interfere with a fixture. The second gauge that's on this slide, the one down below, is a dual shear pattern, and this one is specially designed for use with testing for shear modulus of composite materials when you've got Yoshipescu type specimens. This test was developed many years ago, where you take a composite and you shape it into where it looks about like a bow tie. You basically cut notches into it, and this gauge is designed to cover the entire distance between the notches in one of these shear modulus coupons.
What if we want to do testing on something other than a shear gauge? What other options do we have?
Yeah, so this next slide shows you kind of a variety of the different types of geometries that we've got for typical strain gauges, and a lot of times you're going to be using these on the composites as well. The first one, the one all the way to the left, is a linear gauge. Very common, very typical for structural testing, also used in coupon testing. 3 out of the 4 of these happen to be our CEA series strain gauges, and you'll notice that because they have larger copper-coated tabs and they're encapsulated. But working from left to right, you've got the linear gauge. The next one is a T-rosette. That's very commonly used for establishing the Poisson ratio for a composite. If you look closely at it, you'll see you've got grids in 2 directions, 90 degrees to each other, and that can be used to establish properties for maybe a new composite that you're building and you're looking for that Poisson ratio. That gauge would be a great one to choose. The next one is a rectangular style rosette. If you look closely at it, you'll see it's got 3 sensitive grids. And the reason that you would use one of those is that you're not sure of direction. So most of the time this is used on a structural application where maybe you're not sure of the maximum strain direction. Well, if you take one of these and you glue it down, you'll find that this gauge, with those 3 separate measurements and some calculations, you can end up finding your unknowns, which are your maximum and minimum principal strain and direction. So if you're unsure of orientation or direction, that's the right type of gauge to use. And then the last one is a dual shear pattern, sometimes known as a chevron, because it obviously looks like a chevron. But this one has 2 grids at 90-degree angles to each other, and they're turned at a 45-degree direction off the long axis. And this gauge is commonly used for torque measurements on a shaft, but also commonly used for shear modulus testing when you're trying to establish material properties. And then the next slide here shows the variety of the different strain gauges, just some of the different patterns that we offer. And that's one of the things you'll find about Micromeasurements offerings of strain gauges. There's a tremendous variety of gauges to choose from. Ones that go down to about 0.008 of an inch active length, all the way up to the longer one, which is 4 inches long. And there's everything in between. So as you are establishing and going through the selection process for your particular test requirements, you'll find most likely you can find the gauge that'll meet your needs looking at our portfolio of gauges.
Customers sometimes ask me what's the difference between the matrix or the overall length, or what are the different words mean for that?
Yeah, that's a fantastic question. So this next slide helps to illustrate, and you'll find these dimensions listed in our catalog. One of the most important things to determine, and especially in gauge selection, is what's the right length. And like I mentioned, we have strain gauges that have a gauge length all the way down to 0.008 inches, or all the way up to 4 inches long, and we've got everything in between. So when you're looking at this image, you'll see what's defined as the gauge length, which is the distance between the end loops of the strain gauge. The grid width is just the width of the sensitive part of that area of a gauge. And the thing to keep in mind when you're selecting the right size is that a strain gauge is an averaging device. So the bigger they are, the more averaging. The shorter they are, the less averaging. Also, though, you'll see other dimensions listed, which include the overall dimensions. That's the overall width and overall length, and that includes the grid and the tabs. And then you'll see the matrix dimensions, which are basically the footprint of the strain gauge. And that's how much area it's going to take up on your part. And you'll see the matrix width and the matrix length. You may find with some of the smaller ones that the matrix is bigger than what you want, and you can trim it down to make it smaller. We just encourage you, if you're going to do that, use a straight edge razor blade like a guillotine and chop it off. And also try to stay outside of the alignment marks, and those are the triangles and the rectangles that you see.
What are some of the different test standards for testing composites?
So there's really 4 that we're probably most familiar with. I'm sure there's a lot more. And these are 4 that we actually go over in the strain gauge composites class that we teach over the summer. The first one's ASTM D695. It's a standard method for establishing compressive properties of composites and plastics. That's the one that I was mentioning earlier, where we have a strain gauge that has the tabs off to the side, because for the run that test you have a fixture where the gauge gets put on a coupon and it gets put inside of this fixture, and there's a limited window for the gauge and the wires. And what we found is that we needed to pull those leads off to the side to be able to get them out of the fixture. The second one is the ASTM D5687. That's kind of a standard guide that's used for prepping the surface and getting it ready for bonding as well as testing. It's kind of a general guideline to use just in general for composites testing. The next one is ASTM D5379. This one is the test method for establishing the shear properties of composites. And earlier we showed you one of those gauges. It's actually a special one that's designed just for this V-notched specimen. We've got two different sizes of gauges for what's known as a compact and a Yoshipescu size specimen. And then the last one is ASTM D3039. That's the standard test method for establishing tensile properties of composites. And it gives you some of the basic things about length versus width ratio for the samples, as well as the size of strain gauge that should be used. And in general, we find the 1/8 of an inch is about as small as you would ever go. A 250 or 1/4 of an inch active length is pretty typical. So here we're taking a closer look at ASTM D695. You can see the shape of the coupon, as well as you can see that we're using the 062 UB pattern with the leads coming out to the sides. And again, that fixture has a very small opening, so that makes that much easier for our customers to use it. And this is just a closer up image of the 062 UB. Again, so you can see that geometry and you can see the leads coming off the side. And this is the page pulled from the catalog. And then we decided to build those in 3 different sizes. We've got them in the 062 size, the 125 UB, and then we also have them in a 250 UB for different size specimens and fixtures that you might use for compression testing. And then this next one is the shear modulus test. This is the 5379. And there are a couple of different sizes and geometries of gauges that we show here. For the Yoshipescu and the compact test, we have a planar style gauge and a stacked. Both are 2-element T-rosettes, and both are 500 ohms in resistance. We also find that customers use our 062 UV. That's the strain gauge near the bottom that's got the 3 copper-coated tabs. That's a pretty common strain gauge that gets used for the Yoshipescu test. The key here is to standardize. You know, you could use one or the other strain gauge, and you can get into the fine details of why you would select one versus another. But in general, what we find is our customers, once they start using one of these types of gauges, they have a tendency to stick with it. And then this is the page from the catalog that kind of shows that. It shows you some of the dimensions and the details. And then the other ASTM test method, the D3039, this is the one where you're establishing tensile properties. This is the one that recommends an active gauge length of 0.25 inches, which is pretty typical for composites so that you get some averaging. And also in this test you might find that you're using T-rosettes if you're trying to establish the Poisson ratio. You can do that using either the CEA style gauges, or also we have an image here showing a C2A series pre-cabled strain gauge, so that all you would have to do is glue the gauge on and maybe put some environmental coating on it, and then you're basically done.
That's great information. So where can I find some help with like the types of adhesives I need to use for different testing and different surface prep materials? I need all that type of information.
Yeah, Mark, that's another great question. And one of the things we worked on in the last few years is to come up with these checklists, and we have one for plastics and composites to try to help guide you through the types of things you need to think about when it comes to strain gauge selection or adhesive selection or environmental coating. For example, with plastics and composites, we find our M-Bond AE10, which is a two-part epoxy, is by far the most common adhesive that's used. And part of the reason for that is it's a thicker, higher viscosity adhesive, so it's better if you've got an irregular surface. And also it's a 100% solids epoxy, so there's no solvent in it, so you don't have to be concerned about solvent sensitivity of the adhesive and how that might react with the plastic or the composite. These checklists, you can find them on our website, or we can email them to you, and you can use that basically as a guide. Some of the things you need to think about when it comes to surface preparation of a composite, first off, is it going to be sensitive to the chemicals that we normally use? And the answer is going to be that it depends on what that material is. Polystyrene, polypropylene, some of those have a tendency to be sensitive to stronger solvents, so you probably want to avoid those during the surface preparation. We also have a tendency to want to use isopropyl alcohol for degreasing. We have another chemical, it's called CSM3 that we use, but we typically use that on metals where we're not so concerned about reactivity, where on composites and plastics we are, and we have a tendency to use isopropyl alcohol for cleaning. But the basic process is still about the same. You're trying to degrease it, you're trying to introduce some texture to it, then you're trying to put a final cleaning on that surface, and oftentimes we will degrease it, do a light abrasion, and scrub it with conditioner and scrub it with neutralizer, and that'll be basically what we do to get it ready.
I really like using the M-Bond 200. It's so easy to use, but you said the AE10's more common. When do I need to know which one I can use?
Yeah, that's another great question. M-Bond 200 in general on composites, it has to fit the application. So you have to look at the longevity of it. So if you're doing coupon testing that's just going to last for a few days, you might be able to get away with using the M-Bond 200, the cyanoacrylate. But you also have to look at the surface and how smooth is it. If it's resin rich on the surface and very smooth, then there's a good chance that you could in fact use M-Bond 200. Again, it needs to be short-term testing, and it also needs to have a very low or narrow operating temperature range. In general, we're looking from about room temperature up to about 150 degrees Fahrenheit. Anything higher than that, then we really need to start looking at something different. AE10, like I mentioned earlier, is by far the most popular for composites. A, it's a long-term adhesive, so you can put it on today and it should be good for 20 years from now, maybe longer. B, it's 100% solid, so there's no reactivity that you have to be concerned about. What you mix up and you put on the surface of that part's going to be there. Also, as you start working with composites, sometimes you find they're more fiber rich at the surface and you can feel that texture, and AE10 is a much better filler for composites. Some applications you have to potentially go beyond the range of AE10. AE10 is going to be rated to about 200 Fahrenheit. And if you start finding that your application goes above that, then you start looking at some of the elevated temperature curing epoxies like our M-Bond 610. M-Bond 610 is not as common just because it's typically used when you're going beyond about 200 degrees Fahrenheit. It's not as common on composites, but you have to watch it as well because it's a solvent-thinned adhesive system, so it's going to go on very thin, so it's really not a good filler. So if you're going to use M-Bond 610, you might have to use another epoxy as a pre-coat. Sometimes you use 610 as a pre-coat. And the other thing you got to keep in mind is the minimum cure temperature with it's about 225 Fahrenheit for 4 hours. So you got to keep that in mind, that you've got to elevate the temperature and you also have to put clamping pressure on it.
Self-heating seems to be a big issue. With our instrumentation, how can we manage that so that we don't damage our testing by adding in thermal strain?
Yeah, so really that comes down to the selection of the equipment that you're going to use and what its capability is. For example, if you're running a basic coupon test where maybe 1 or 2 or up to about 4 channels, you can start looking at our P3 strain indicator. And the P3 strain indicator only uses a 1.5 volt excitation and it's pulsed. When you're testing composites, in general, they're not good heat sinks, so you have to be concerned about that, because if you put too much excitation in, then you can create an unstable signal. So, for example, the P3 at 1.5 volts, normally that's not going to be an issue. The P3 will accept 120, 350, or 1,000 ohm strain gauge, and in general, we lean you towards 350 and 1,000 ohm gauges for composites testing. Now, if you've got more channels, you might look at, for example, in our system 8000, and it can accept 120, 350, and 1,000 ohm gauges. And you've also can vary the excitation with it anywhere from about 1/4 of a volt up to a 10 volt excitation. So you've got a very broad range to choose from in terms of establishing what's the right excitation level. And in general, on composites, we normally recommend that you start at 2 volts, because normally for most applications that's a safe level. And if you may find if you start at 2 for very small gauges on composites, you might have to lower it, and what you would be looking for is a little bit of drift just due to turning the equipment on. This is another example of the shear modulus testing, and this shows the actual coupon, and you can see the shape of it, sort of like a bow tie. And you'll see the 2 notches, and the gauges are sized to cover that entire distance between those 2 notches. The reason for that is it helps to make the shear modulus calculations much more repeatable as you start testing materials that have various fiber directions. If you were covering just a small section in between the 2 notches, you'd find more scatter in your data when you start calculating this shear modulus as the fiber orientation were to vary. So to make that more repeatable, we've developed strain gauges somewhat or years ago that will help to average out some of that non-uniformity that you start to see as you have different orientations of fibers. So just to kind of summarize, we like to think of ourselves as one-stop shopping. We offer everything from the strain gauges to the adhesives to the instrumentation that you would be able to use for either coupon testing or structural testing, not only of composites but metals and plastics and other materials as well. And we like to think we have a variety of different gauges to choose from, some with wires on them, some without. And I think you'll find if you follow our procedures that we have outlined for gauge installation, you can achieve very good resolution and accuracy out of these types of measurements. Great questions, Mark. I appreciate you taking the time to go through this PowerPoint presentation and to discuss strain gauges on composites.
Thanks, Darryl. This was really helpful. Great information.
Thanks, Mark. And keep in mind, too, that we have a staff of applications engineers at the ready to answer any technical questions you have related to strain gauge testing of composites. Also, you can check out the website at www.micro-measurements.com. And also, you can go to the Strain blog at www.strainblog.com to find out more information related to strain gauges as well as strain gauge testing of composites.